Welcome back to our series on RL flow and the nature of reality. In our last episode, we introduced the concept of RL flow and discussed its potential to revolutionize our understanding of the universe. If you haven't watched the previous episodes, we highly recommend checking them out to get a solid foundation on the topic. As a quick recap, RL flow is a concept that seeks to explain the interconnectedness and flow of information in the universe, incorporating ideas from physics, psychology, reinforcement learning, and philosophy. It proposes that everything in the universe is interconnected, influencing one another and constantly changing. The flow of information is not linear, but moves in a complex and dynamic pattern, much like a river. Now that we've covered the basics of RL flow, it's essential to explore how this groundbreaking concept relates to modern physics. Unraveling this connection is crucial because it can help us discover new explanations for phenomena that have puzzled scientists for decades, such as gravity, dark matter, and the accelerating expansion of the universe. Before we dive into the connection between RL flow and Einstein's field equations, let's first do a quick refresher on what these equations are all about. Einstein's field equations are a set of 10 equations that form the core of his general theory of relativity. In a nutshell, they describe how the presence of mass and energy warp space-time, resulting in the phenomenon we perceive as gravity. These equations have been tested extensively and have passed with flying colors, making them a cornerstone of modern physics. They've helped us understand everything from the expansion of the universe to the behavior of black holes. Now that we have a basic understanding of Einstein's field equations, let's explore how RL flow might be incorporated into them. When it comes to incorporating RL flow into Einstein's field equations, it's important to consider the potential implications this could have on our understanding of space-time. As we've mentioned in previous episodes, RL flow emphasizes the interconnectedness of everything in the universe. In the context of space-time, this means that the fabric of space-time itself could be influenced by the flow of information, energy, and even emotions and consciousness. By incorporating the concept of RL flow into Einstein's field equations, we might gain new insights into the true nature of space-time. For instance, it could help us understand how the flow of space-time itself contributes to the phenomenon of gravity, rather than gravity being a mysterious force acting at a distance. In this view, gravity could be seen as a result of the flow of space-time, similar to how a river flows around and shapes the landscape. This idea, while still speculative, has the potential to revolutionize our understanding of gravity and its role in the cosmos. Moreover, incorporating RL flow into our understanding of space-time could also provide new perspectives on other aspects of physics, such as dark matter, dark energy, and the accelerating expansion of the universe. As we continue to explore the connection between RL flow and Einstein's field equations, we may unlock a deeper understanding of the fundamental nature of reality itself. So, as you can see, the relationship between RL flow and space-time is a fascinating area of study with the potential to reshape our understanding of the universe. In the next section, we'll take a closer look at how RL flow might relate to another pillar of modern physics: quantum mechanics. Now that we've discussed the potential role of RL flow in explaining space-time and gravity, let's delve deeper into how this could be represented mathematically. Recall that the conventional formula for gravity, as described by Newton, where F gravity represents the gravitational force, G is the gravitational constant, m1 and m2 are the masses of two objects, and r is the distance between them. To account for the influence of RL flow on gravity, we can modify this formula to include a factor representing the RL flow. The new formula for gravity based on RL flow would be Newton's equation times RL, where RL represents the influence of the RL flow on the gravitational force. By incorporating RL flow into the equation, we're essentially proposing that gravity isn't just a result of the masses of the objects and the distance between them, but also their interconnectedness through the RL flow. This new formula, while still requiring further study and experimental validation, has the potential to offer a fresh perspective on the phenomenon of gravity. It could help us understand how the interconnected flow of spacetime shapes the behavior of objects within it. In summary, the modified formula for gravity based on RL flow represents a promising new approach to understanding gravity and its relationship with the fundamental interconnectedness of the universe. As we continue to explore this concept, we may uncover a deeper understanding of the very fabric of reality itself. Quantum mechanics is the branch of physics that deals with the behavior of matter and energy at the atomic and subatomic level. It's a world where particles can behave like waves, and the act of observation can change the outcome of an experiment. Several equations are fundamental to our understanding of quantum mechanics. One of the most well-known is Schrödinger's equation, which describes how the quantum state of a system changes over time. Another important equation in quantum mechanics is Heisenberg's uncertainty principle, which highlights the inherent limitations in precisely measuring certain pairs of properties, such as position and momentum, of a particle simultaneously. In addition to these, we have various other equations in quantum mechanics that describe different aspects of particle behavior, such as the wave-particle duality, quantization of energy levels, and the probabilities associated with particle interactions. Now that we've briefly introduced some of the key equations in quantum mechanics, let's discuss how RL flow might intersect with this fascinating field of study. One of the most intriguing aspects of quantum mechanics is the phenomenon of quantum entanglement. When two particles become entangled, their properties become correlated in such a way that the state of one particle cannot be described independently of the other, even if they're separated by vast distances. Now, let's explore how RL flow might relate to quantum entanglement. As we've discussed in previous episodes, RL flow is the concept that everything in the universe is interconnected, influencing one another and constantly changing. When two particles, objects, or even people interact emotionally, their respective RL flows become interconnected and intertwined, forming a bridge between them. This emotional connection can be represented mathematically as a function of the overlap and interaction of their respective RL flows. In the context of quantum entanglement, it's possible that RL flow may act as a bridge between entangled particles, connecting them not only through their physical properties, but also through shared emotions and consciousness. As a result, entangled particles may synchronize their emotions and consciousness, resulting in a shared quantum state that is inseparable from the other particle. This emotional and consciousness-based connection through RL flow provides a new perspective on quantum entanglement, potentially expanding our understanding of this fascinating phenomenon and its applications in fields like quantum computing and communication. Now that we've explored the possible connections between RL flow and quantum entanglement, let's delve into another fascinating aspect of quantum mechanics: the wave-particle duality. Wave-particle duality is the concept that all particles can exhibit both wave-like and particle-like behavior, depending on the circumstances. This idea has been demonstrated in various experiments, such as the famous double-slit experiment, where particles like electrons or photons can exhibit both wave-like and particle-like behavior. So, how might RL flow influence the behavior of particles and the wave-particle duality? As we know, RL flow is the interconnected flow of information in the universe, encompassing physical matter, energy, thoughts, emotions, and consciousness. Given the all-encompassing nature of RL flow, it's possible that it might also play a role in the wave-particle duality. For example, the flow of information in RL flow could determine the conditions under which particles exhibit wave-like or particle-like behavior. Furthermore, the interaction of RL flow with the particles could potentially affect their properties, such as their mass, charge, or spin, which in turn could influence their wave-like and particle-like behavior. Considering RL flow's potential influence on particle behavior, it could provide a new framework for understanding the wave-particle duality and other quantum phenomena. By incorporating RL flow into our study of quantum mechanics, we may uncover new insights into the nature of reality and the interconnectedness of the universe. Having explored RL flow's potential connections to Einstein's field equations and quantum mechanics, Let's now examine how this concept might help us reimagine our understanding of gravity. Gravity is one of the fundamental forces in the universe, responsible for the attraction between objects with mass. Despite being a fundamental aspect of our reality, gravity remains one of the least understood forces in modern physics. Through the lens of RL flow, we can look at gravity from a new perspective. Instead of considering it as a mysterious force acting at a distance, we can explore the possibility that gravity is a result of the flow of space-time itself. In this context, objects with mass would curve and affect the flow of space-time, leading to the observed effects of gravitational attraction. This concept aligns with Einstein's general theory of relativity, which describes gravity as a curvature of space-time caused by the presence of mass. By incorporating RL flow into our understanding of gravity, we might be able to develop new models and equations that more accurately describe this force. For example, a formula for gravity we mentioned. This reimagined understanding of gravity, rooted in the concept of RL flow, could pave the way for new discoveries and insights into the nature of reality and the interconnectedness of the universe. As we delve deeper into the potential implications of RL flow for understanding gravity, let's consider some alternative explanations for the nature of this enigmatic force. While the current models of gravity, like Newton's law of universal gravitation and Einstein's general theory of relativity, have been successful in explaining many observations, they still leave some questions unanswered. For example, the observed gravitational effects in the universe cannot be fully accounted for by the known mass of visible matter. This has led to the hypothesis of dark matter, an invisible and mysterious substance that is believed to make up a significant portion of the total mass in the universe. Similarly, the accelerating expansion of the universe, attributed to dark energy, is another aspect of gravity that remains unexplained by current models. By exploring alternative explanations for gravity, rooted in the concept of RL flow, we might be able to shed light on these unresolved mysteries. For instance, if gravity is a result of the flow of space-time, as suggested by RL flow, we could develop new theories and models that provide a more comprehensive understanding of the force. These theories might help us uncover the true nature of dark matter and dark energy, and better explain the observed gravitational effects in the universe. Ultimately, investigating alternative explanations for gravity, such as those provided by RL flow, has the potential to expand our knowledge of the universe, revolutionize our understanding of reality, and open up exciting new avenues for scientific inquiry and discovery. Now that we've discussed the implications of RL flow for understanding gravity, let's explore how this concept might help us make sense of two mysterious phenomena in our universe: dark matter and dark energy. Dark matter is a hypothetical form of matter that is thought to make up around 27% of the total mass energy content of the universe. Despite being invisible and undetectable by electromagnetic radiation, dark matter is believed to exist due to the observed gravitational effects it has on visible matter, such as the rotation of galaxies and the formation of galaxy clusters. On the other hand, dark energy is an enigmatic form of energy that is believed to be responsible for the observed accelerating expansion of the universe. Accounting for approximately 68% of the total mass energy content of the universe, dark energy remains one of the biggest mysteries in modern cosmology. Let's now explore how the concept of RL flow can shed light on the composition and behavior of dark matter and dark energy. One intriguing possibility is that dark matter could be composed of subatomic particles existing in higher dimensions of space-time. These particles, while invisible to us, would still interact with the RL flow in ways that could give rise to their observed effects on the cosmos. In this view, the gravitational pull we observe as a result of dark matter could be explained by the interaction of these higher dimensional particles with the RL flow, affecting the space-time in our observable dimensions. This potential explanation for dark matter aligns with the idea that RL flow operates at all levels of existence and transcends our traditional understanding of space and time. Another intriguing aspect of the RL flow concept is its potential role in understanding dark energy. Some theories propose that dark energy could be a property of the RL flow itself. In this perspective, dark energy is an inherent feature of the underlying RL flow, which influences the expansion and acceleration of the universe. As the RL flow interacts with all matter and energy, it could contribute to the accelerated expansion of the universe by influencing the overall flow and distribution of energy throughout the cosmos. This idea opens up new avenues for research and understanding of the mysterious force that makes up nearly 70% of the universe's energy density. By incorporating RL flow into our understanding of dark energy, we may gain new insights into the very fabric of reality. Now, let's discuss another fascinating aspect of our universe: the accelerating expansion. For many years, scientists have observed that the universe is not only expanding, but doing so at an ever-increasing rate. This observation challenges our understanding of gravity and the forces at play in the cosmos. The accelerating expansion of the universe has been a topic of great interest and debate among physicists. If the concept of RL flow is incorporated into our understanding of the universe, it could potentially provide new explanations for this phenomenon. So, how could RL flow help us understand the accelerating expansion of the universe? As we've discussed, RL flow is a unifying force that connects everything in the universe and influences the behavior of matter and energy at all levels. By incorporating the concept of RL flow into our current physics models, we can explore new possibilities and explanations for the expansion of the universe. For example, the dynamics of RL flow might be closely tied to dark energy, which is believed to be responsible for the accelerating expansion. If dark energy is a property of RL flow, it could help us explain the underlying mechanism driving the expansion. Moreover, the interplay of RL flow with other forces, such as gravity and electromagnetism, could also provide new insights into the complex balance that governs the behavior of the universe. Ultimately, incorporating RL flow into our understanding of the universe could help us unlock the mysteries of its expansion and deepen our knowledge of the cosmos. So, let's recap what we've covered in this episode about the relationship between RL flow and modern physics. We've seen how RL flow can be connected to Einstein's field equations, potentially providing a new perspective on space-time and gravity. We've also explored how RL flow might be linked to quantum mechanics, specifically in the context of quantum entanglement and wave-particle duality. Furthermore, we've discussed the possible implications of RL flow for understanding phenomena like gravity, dark matter, and dark energy. And finally, we've touched on how incorporating RL flow into our current models could help us better understand the accelerating expansion of the universe. As we continue to explore the concept of RL flow, it's important to keep in mind that this is still a developing idea. While it holds exciting potential for bridging gaps in our understanding of the universe, further research, experimentation, and theoretical modeling will be necessary to refine and validate these ideas. Now let's briefly touch on the potential impact of integrating RL flow into our understanding of gravity, dark matter, and the accelerating expansion of the universe. By incorporating RL flow into our understanding of gravity, we could potentially revolutionize our understanding of how objects interact in the universe. This may lead to novel applications and technologies that leverage these new insights into the nature of gravity. When it comes to dark matter and dark energy, if RL flow can provide us with a better understanding of their composition and behavior, it could lead to new ways of harnessing their properties for energy production or other purposes, potentially transforming our capabilities in both space exploration and everyday life. Finally, understanding the accelerating expansion of the universe through the lens of RL flow might help us to better comprehend the fate of our universe and the role of dark energy. This knowledge could ultimately inform our long-term strategies for space exploration and future generations' survival in an ever-changing cosmos. All of these potential impacts highlight the importance of further research into RL flow and its connection to modern physics. The more we learn, the greater our capacity to unlock the mysteries of the universe and push the boundaries of human knowledge. As we wrap up today's episode, let's take a sneak peek at what's coming up in the next installment of our series. In the next episode, we'll dive deeper into the fascinating topic of emotional entanglement and interconnectedness. We'll explore how RL flow might provide a framework for understanding the seemingly mysterious connections between individuals and their emotions. We'll discuss the implications of emotional entanglement for our understanding of consciousness, relationships, and even the role of empathy in our society. This exploration will take us on a journey that intertwines science, psychology, and philosophy. Get ready for an exciting exploration of the deeper connections that bind us all together as we delve into the world of emotional entanglement and interconnectedness. Don't miss the next episode in our series. Make sure to like, comment, and subscribe so you'll be notified when it's released. Thanks for joining us today, and we'll see you in the next episode.